Hey physics students, what I'm going to do for you tonight is I'm going to do 3 problems that are actually in the packet that you have, which you can also get on Edmodo if you lost it. And I'm going to kind of walk you through it so you can see what you're supposed to do and how you're supposed to figure out what equations to use. And that's pretty much it. And I guess send me a message if you are confused and if you need any extra help. Okay, so for our first problem, which is number 89 in the questions packet, it says an object is moving with an initial velocity of 19 meters per second. It is then subject to a constant acceleration of 2.5 meters per second squared for 15 seconds. How far will it have traveled during the time of its acceleration? So the first thing we have to do is we have to list our givens. So if we look through, it says an object's moving with an initial velocity of 19 meters per second. So we know we're given a velocity, and since it's what it's already doing, then we know that that's our v naught. So our v naught equals 19 meters per second. It then says it is then subject to a constant acceleration of 2.5 meters per second squared. So we know our a for acceleration is 2.5 meters per second squared. And just a hint, if you see meters per second squared, you know it's the acceleration, because that's the only thing that has that unit. And it says it's for 15 seconds, so seconds we know is time, so 15 seconds. How far will it have traveled during the time of its acceleration? So if remember how far x marks the spot where we end up, so x is what we're looking for, our distance, and we assume x naught equals 0. So now the next step for these problems is to figure out what equation you want to use. So if you look, we've got v equals v naught plus at, x equals x naught plus v naught t plus 1/2 at squared, and v squared equals v naught squared plus 2a x minus x naught. So the first thing we need to look at is we want to solve for x, and the first equation doesn't even have an x in it, so we can't use that one. The next two have x in them, but if we look, this one requires v. We don't have a v. T. So we know we can't do this one because there's no t and we don't have a v in our givens. This one, we have everything we need. So we write out the equation. X equals x naught plus v naught t plus 1/2 at squared. And next step is to cancel out anything that's a 0. So we know we can cancel out our x naught. And we can rewrite the equation as x equals v naught t plus 1/2 at squared. Since we're solving for x, if we look, x is already by itself, so we don't have to move anything around. So the next step is just to plug our numbers in and solve. So x equals our v naught, which is 19, times our t, which was 15, plus 1/2, times our a, which is 2.5, times our t, which is 15, and we need to remember to square it, because that t is squared. So we can do the next step in the equation. We can do this right here, because they're by themselves, 19 times 15, which gives us 285, plus we can leave the 1/2 and the 2.5 right now, so that we can do this 15 squared. And our 15 times 15 gives us 225. And now we want to continue this multiplication. So our 285 is going to stay there by itself for a second. And now we want to do 0.5 times 2.5 times 225, which gives us 281.25. And now the next step is just to add them together. So now we're going to take that and we're going to add 285 to it. And our answer that we get is 566.25 meters. So that's problem number 89. Okay, so now we've got number 98. And it says an object accelerates from rest with a constant acceleration of 7.5 meters per second squared. How fast will it be traveling after it goes 87 meters? So, the first thing we need to notice is it says it accelerates from rest. So if it's accelerating from rest, it's not moving. so which means it has no speed in the beginning. Think of like a parked car. It doesn't have a speed on the speedometer. So that means our v naught, our initial velocity, equals 0. It then says it has a constant acceleration of 7.5. So our a equals 7.5 meters per second squared. How fast will it be traveling after it goes 87 meters? Well, we know the distance is 87, so that means our x, which marks the spot, is 87 meters. And our x naught is usually 0 if it's not given. When it asks how fast it's going to be going, remember we're talking about speed. You talk about how fast a car is going. That's the speed, that's the velocity. So that means we're looking for the final velocity. So now, if we have all of our equations, v equals v naught plus at, can we do this one? No, because we don't have a t, so we can't do that, and we're given an x, and it's not in that equation, so we can cancel that out. The next is x equals x naught plus v naught t plus 1/2 at squared. Can we use this one? It looks like we could, but the only thing is we're solving for v, and this has a v naught, not a v, so we can't use this one either. So we cross that one out. Which means the last one we have left is v squared equals v naught squared plus 2a x minus x naught. And if you look, we have everything given for that one. So what we're going to do is we're going to write our equation. V squared equals v naught squared plus 2a x minus x naught. And our first step, remember, is to always cancel out things that are 0. So since our v naught is 0, we can cancel out this whole v naught squared. Because remember, 0 squared is still going to be 0. And we can cancel out the x naught. So we can cancel out this whole part. So what we're left with is just v squared equals 2 times a times x. Next thing we want to do is we want to get v by itself. So if we look, it looks like v is by itself. However, this says v squared. We want just v. So the way we cancel out that square is by taking the square root, since it's the opposite. And those are my dogs. So now we've got, there they go. So now we have v equals the square root of 2 times a times x. So now that v is by itself, all we have to do is plug in the numbers. So we have v equals the square root of 2 times 7.5 times 87. Next, we just have to multiply straight across. So 2 times 7.5 times 87 gives us 1,305. And then we just have to remember to take the square root. So square root of that answer equals 36.12 meters per second. And that's how you solve that one. Alright, so our last problem is number 97, and it says a water drop falls down from the roof of a house during 3 seconds. How high is the house? So it looks like we're only given 3 seconds, but really you're given a lot more. So we know that the time is 3 seconds, so we can write that down. T equals 3 seconds. Now we're also given, it says it drops, it falls. So it's not moving in the beginning, it's just at rest before it falls. So that means our initial velocity, our v naught, is going to be equal to 0 because it didn't have any speed in the beginning. Then it says since it's dropping, we remember that free fall means that we have gravity, which means our acceleration is negative 9.8 meters per second squared. And we know if it falls from the top of the house, in the end it needs to hit the ground, which means our x, our final location, needs to be 0 meters. So what we're solving for then is our x naught. So we've got our question mark for our x naught. So now, what we want to do is we want to figure out which equation we're using. So we can't use the first one because we know there's no x naught, so we can cross that one out. The second one has an x naught, and the third one has an x naught. If you look, we're given time. So this one is the only one that has time, so we can cancel that one out. So that means we're using x equals x naught plus v naught t plus 1/2 at squared. Next step, we know we have to cancel out things that are 0. So our v naught is 0, which means we cancel out the whole v naught t. Because remember, 0 times any number is going to give you 0. So you don't need any of that. We also know that our x is 0. Now, we want to cancel this out, but what I like to do is just replace it with a 0, because or else you're not going to have anything on that side of the equation. So now you've got 0 equals x naught plus 1/2 at squared. And remember, we want to get this x naught by itself, since that's what we're solving for. And since the 1/2 at squared is being added, the opposite would be to subtract it. So minus 1/2 at squared. And we do it on both sides of the equal sign. So it cancels out here. So now we're left with 0 minus 1/2 at squared equals x naught. So now all we need to do is plug our numbers in. I like to move the 1 by itself to the left side, so I'm going to rewrite it as x naught equals 0 minus 1/2. Our a was negative 9.8. And our t is 3, and then squared, because remember that t has to be squared. So now you've got x naught equals 0 minus 1/2 times negative 9.8, and our 3 squared is going to be 9. And now you just have to multiply these across. So we've got x naught equals 0, 0 minus, or actually, yeah, we could do 0 minus. Now we've got 0.5 times negative 9.8 times 9, which gives us negative 44.1. And now a minus a negative becomes one big plus sign. So 0 plus 44.1 means our x naught 0.1 meters. So that basically means the house was 44.1 meters high. Now, if you by accident mixed these up, if you look, you wouldn't have that 0 minus anymore, and you would have only had the negative in the 9.8, which means you would have gotten a negative number, which would not have made sense because you can't have a house that's negative 44.1 meters high. So that is that one. Alright, ladies and gentlemen, so those are 3 example problems, and you're going to want to follow the same kind of steps. You're going to want to read the problem, figure out your givens, you're going to want to figure out which equation you can use of the 3, cancel out zeros, move it around, plug the numbers in, and solve. So make sure you have numbers 90 to 94 done for class on Friday, and I will be checking for it. And make sure you answer the question on Edmodo that will be given. Have a good night, guys. See you Friday.